Hello everyone, today we are going to see the determination of surface tension of a liquid sample. The method we are going to use for the determination of surface tension is drop number method. So in this method, we have to measure the number of drops formed in a certain volume of a water and liquid. So by measuring the number of drops, we can calculate the surface tension of a liquid. So here some data is given. Here TW means surface tension of a water is given to us, which is 72.8 dynes per centimeter. Also density of water is given, which is 1. Density is the mass upon volume. So density of liquid is 1.021 gram per ml. These values are given to us, and what we have to measure? We have to measure number of drops of water and number of drops of liquid. By measuring these two values, we can calculate the surface tension of a liquid. The formula to calculate surface tension of a liquid is number of drops of water into density of water into surface tension of water divided by number of drops of liquid into density of liquid. In this formula, these values are with us. Density of water is 1, surface tension of water is 72.8 dynes per centimeter, and density of liquid is 1.021. These values are given to us. What we have to do in this experiment? We have to just measure the number of drops of water and number of drops of liquid that can be flown from the burette. By measuring these values and by putting these values here, we can easily calculate the surface tension of a liquid. So surface tension is a very important property of a liquid, which is having a lot of effects on the liquid properties and its applications. So it is very essential to know and to measure and to determine the surface tension value of a liquid, and by using this very simple method, drop number method, we can easily determine the surface tension of any liquid sample. What we have to do? We have to just measure the number of drops of water and number of drops of liquid, and by putting these two values in this formula, we can easily calculate the surface tension of a liquid. Thank you. Hello friends, today we are going to perform the experiment, and the aim of this experiment is to determine the surface tension by using drop number method. So for the determination of surface tension of a liquid, we required one burette, beaker, water sample and liquid sample. So first of all, what I have filled this burette with water, and now I will allow water to pass through the burette, but by forming the droplets. Likewise, we can allow this burette to form droplets. And now what we have to do? We have to measure number of drops that can be flown by from this burette in a ml. So we are going to pass certain volume from this burette, and from that certain volume, how many number of droplets can be formed, that we have to measure by using the water. This reading can be noted as a NW, where N is the number of drops and W for water. And by replacing this water with the solution or solvent whose surface tension is to be determined, we can again take number of droplets of a liquid, NW. So likewise, in a 1 ml we can measure number of drops of a water, and by replacing this water with solvent whose surface tension is to be determined, we can measure number of droplets of liquid, can be formed. And by putting these values NW and NL in a formula, we can easily calculate the surface tension of a liquid. I am revising. NW means number of droplets of water, and NL means number of droplets of a liquid can be formed. So we are just allowing this water to flow by forming droplets, and we are measuring number of drops in 1 ml for water, and that will be our NW, and number of drops of liquid, that will be our NL. So by measuring